So welcome to an intense review for Algebra 2 for your Regents. We're going to start off with a big topic called polynomials. And so just to refresh your memory about polynomials is basically like when you have terms and they are attached by a positive or plus or a minus sign. That is what a polynomial is. It means more than one term. So the other thing that you need to make sure that you remember is factoring. Okay, so there are a bunch of different ways to factor. First thing is greatest common factor. So we can look and see there is something that is common in all of these. So we'll go ahead and get started with that. There's a difference of perfect squares. There is a dividing or factoring trinomials. And then the last one, these are all from Algebra 1. And the last one that is more so heavy on Algebra 2 is something called grouping. So they are going to make sure that you know how to do some grouping, okay? So we're going to go ahead and get started with the first one. And like we said, we're going to first check if there's any greatest common factors, and there are, right? M, M, M. So we're going to take that M, we're going to factor it out, okay? And so now if we take this and divide it by m, or we have like take out one of the m's, we're going to have four m's left over. Out of this m to the third, if we take out one of our m's, there is going to be m squared. And if we take out our m here, there's going to be a minus 6. Okay, so now they're banking on the fact that you're going to look at your answers and go, oh, 3. But there is a word here that says completely. So automatically off bat, let me just kind of backtrack a little bit right here. See the m and m here, this is not factored completely, so that is out. If I look at this one and I FOIL this out, I do not get m to the fifth. M times m is m squared, so that is automatically out. And again, they want us to choose 3, and we're going to see why it's not 3, okay? The reason why it's not 3 and why it's 4 is because our m is already factored out, as we talked about, okay? And then m to the fourth plus m squared minus 6, that might be a little bit harder to factor, but you know how to factor something that looks like this, okay? This is pretty straightforward, right? We're looking for two numbers that multiply to give us negative 6 and that add to give us 1, right? There's an imaginary 1 right here. So that's going to be 3 and negative 2. All right, so now we can go ahead and say, if I were to factor this simpler problem, I could do this as x plus 3 and x minus 2, and then I'd be done with this, right? Okay, so how does that apply to what we're doing right now, right? Remember, our m comes straight down, and then here, right, instead of our x, let's plug in m squared. So we have m squared plus 3 and m squared minus 2, okay, which is what answer 4 says. And again, they are banking on the fact that you are not going to know that you can factor those out. And again, if you're like, hey, how do I do this without with the calculator? You can use the store button here because it does say is equivalent to. There are two that are gonna give you the same answer as the original. So if I store in 2.1, which is my lovely number to always store, right? Take 2.1, store it in for x. We're gonna see that both 3 and 4 give me the same answer, but 4 is the one that is completely factored. Keyword here is completely factored, okay? All right, so the zeros for a function. So very easily and they love asking these questions about zeros. They'll ask this on every single Regents. So I just went into y equals and I graphed it, and then I'm going to go to my table. So zeros are where my y's are zeros. Okay, so here's my y. I'm looking for where there are zeros here. And there should be 4 of them. So let's see if I can figure these out. So, okay, so 0, right at 0, there is a 0. Okay, so all of them have zeros in it. If I keep looking down, 3 and 4 also have zeros. So 3 and 4 also have zeros. Okay, so automatically I can get rid of this right here and this one right here because that has negative 4, not positive 4. And now let's see if negative 3 works. If negative 3 works, then our answer is going to be choice 1. So let's go up. And boom, across from negative 3, there is another 0. So here are my zeros, right? 0, positive, and negative 3, and 4. Okay? Number 2 is not including the -3. All right. And again, a question like 27, they have usually asked this on the Regents. Here's a simple way to do this, right? Determine if x minus 5 is a factor. This is called remainder theorem. So what you do is take our x minus 5, set it equal to 0. What is x equal to? X is equal to 5. So I'm going to take 5 and I'm going to store it in for my x. Okay, so 5, store x, hit enter, and then I'm going to plug in my expression. And if when I hit enter here, I get 0, then the answer is yes, it is a factor. If I don't get 0, I get any other number, then no, it is not a factor. So let's see. So the answer is no, right? So no, x minus 5 is not a factor because the remainder is 105 and not 0. Okay, and there we go. And since it says explain, I need to write the sentence out, otherwise I will not get full credit. Okay, so if you understood what we did with the problem above, this next one should be pretty straightforward, right? So I do the same thing. X minus 1 is equal to 0, add 1, and I get x equals 1. So this must be a factor of our expression right here. So what I'm going to do is I'm going to take 1, and wherever I see an x, I'm going to plug in a 1, and I'm going to set it equal to 0. So I have 1 to the third power minus k, because I'm looking for k, 1 squared plus 2 times 1. And again, it's a factor, so I'm going to set it equal to 0. And now I just need to evaluate this, right? 1 to the third is 1. 1 squared is also 1. So this is 1 minus k plus 2 times 1 is 2 is equal to 0. 1 plus 2 is 3 minus k equals 0. Add k to both sides because I want to get the k by itself, and I get k is equal to 3. Okay, boom. So my answer is choice 3. All right, we're doing good so far. So this is also remainder theorem. You could use store button here, right? Store number 2.1, store it in for x, plug this whole thing in, hit enter, write that answer down, and whichever one matches with it is going to be your answer. If you're like, hey, show me another way to do this question, sure, okay? So I'm going to take this one right here, and I'm going to set my denominator here, 2x plus 3. I'm going to set it equal to 0. So minus 3, okay, so 2x is equal to -3, divide both sides by 2. So I get x equals -3 over 2. So what we do now in our calculator is I'm going to store negative, right, alpha y equals to get my fraction bar, 3 on top, 2 on the bottom. I'm going to store this in for x, hit enter. And then if I plug in my numerator, which is the top right here, that answer is going to give me my remainder. Let's see what my remainder is, right? So all my remainders are different. Okay, so let's see. So 4x to the third, right? So when I plug it in, I get -11, which means that my remainder is -11. So which one has that, right? So this one says it's a remainder of 31. This is -11, so this is my answer. This one says it's a remainder of 15, and this one says it's a remainder of -20. Okay, so answer choice 2 is our answer for this question. All right, so this next one, let's talk about zeros, right? So the zeros are right here. They are at -4, 0, and 3, okay? So if I said to you, what are my factors? I would take those 3 numbers right there and I would switch the sign. So this is going to be x plus 4, x plus 0, which is just x, and x minus 3. Basically switch the signs, okay? So now it says, what is the remainder when p of x is divided by x plus 4? Since x plus 4 is one of my factors, my remainder is going to be 0, right? Remember what a remainder is. It's a factor if the remainder is 0. Factor if remainder equals 0. If it's not 0, if it's any other number, then it's not a factor. Okay. All right. So for the next one here, they're telling us that the zeros of a quartic just means like you have x to the fourth, and there are 4 roots. They actually give us all the different roots or the x-intercepts or the solutions or the, yeah, roots, solutions, x-intercepts, and zeros all mean the same thing, okay? So let's go ahead and we want to start out by graphing 3, 4. So they tell us that -2, +2, right? So if I go to -2, I put a dot. I should label it +2, put a dot, 4 and -4. So at 4, there's also another one, another 0, and at -4, there's another 0, okay? So it's telling us the zeros, and they're asking us to construct a possible sketch. So possible sketch. So we've done this before. Okay, so end behavior, remember, like for any even is going to be facing the same way. If the leading coefficient is positive, then it's going to go up. If it's negative, it's going to go down. So like, for example, x squared is going to go up and negative x squared is going to go down, okay? So they're just asking us to sketch what this looks like, okay? So we're going to go something like, we know that our end behavior is going to be the same because it's an even, right? 4 is an even number. So if I go something like, let me reverse there for a second, okay? Let me go through it. So I just have to go through here, come up, come down, come up, and show that I know that our ends are going to be facing in the same direction, okay? So this is what a quartic function could look like. That's one possible sketch. Another possible sketch is if I had a negative leading coefficient, like a negative x to the fourth, what could this look like, right? It would look like the flip. So I could go something like this, come down, come up, come down, and these both would be facing in the down direction. So I can draw either the blue graph that I just drew or the burgundy/red graph that I just drew. Either one, okay? Don't draw both. All right, for this one, this is Unit 1, Lesson 2. It's our second lesson that we did in September, second lesson of the year. I don't know why I can't write our U. There we go. So the first thing that we want to do is we want to get our weird thing by itself. So we want to get that radical 2x minus 7 by itself. Let's move that x over here to the other side. So this cancels out. So I have square root of 2x minus 7 equals 5 minus x. Beautiful. Okay. Now, how do we get rid of our square root? We get rid of the square root by squaring. The opposite of square root is a square. Whatever I do to the left, I do to the right. So these two babies right here are going to cancel each other out, okay? And we're left with 2x minus 7 equals 5 minus x. We're going to write it twice. Now it becomes a straight algebra 1 question. Let us do this. So 5 times 5 gives us 25. You could use box method here. 5 times negative x gives us negative 5x. Negative x times 5 gives us another negative 5x, and negative x times negative x gives us positive x squared. So this is 2x minus 7. So we're going to zero this out, which means that we're going to move everything over to one side. So let me do this in a different color. So minus 2x, and plus 7, plus 7. Do you see how I lined these up? So this is going to be easy for me to do. So this is going to be 25 plus 7 is 32. 10, so this is minus 12x, and this is plus x squared. This irks my soul writing it like this, so I'm going to write x squared minus 12x plus 32 is equal to 0. I even might want to put my equal 0 on that side. Yeah, that's better. Okay, so now I'm going to go ahead and find out two numbers that multiply to be 32, and that also add to give me negative 12. 8 and 4 is coming to mind. So 8 and 4 to multiply to give me a positive, both, and add to give me a negative. Both of them have to be negative. So I'm going to get x minus 8 and x minus 4. Set them equal to 0. Okay, almost done. I'm going to split this. X minus 8 equals 0. X minus 4 equals 0. So switch the sign here. I get x equals 8 is one possible solution, and x equals 4. Remember to switch the sign, okay? Now, this, a lot of people are going to just want to stop here. Don't stop. Check your answer. And how do you do that? With the calculator, okay? Let's just say you didn't know how to do any of the things that I just did on this question. You could go straight calculator, get 1 point for this question. Listen, 1 point is better than no points, okay? So let's do this. Come on. So second x squared gives me the square root 2x minus 7. And then I have plus x. Notice what I'm doing, right? I'm going back to my original. See my original? Do you see my original right here, right? So I'm going back to my original, plugging this whole thing under y1, plugging this under y2, okay? So over here, I'm going to go to my y2. I'm going to go to 5. And now I'm looking to see where they meet. So my critical values are 8 and 4. All right, so automatically there's a problem right now. They only cross at one of them, okay? So if I'm not sure which one, I mean, I can count, but if I'm not really sure, I can go to my table here, and I'm looking to see where my y1 and my y2 are the same. See this? Boom, 5, 5. So x equals 4 is a valid solution. This does work out. Let's check 8. Across from 8, do we have the same numbers? No, I don't. So x equals 8 does not, it does not work out. So I'm going to cross it out, okay? Leave the answer on your paper. If you want to be very clear, you could even write x equals 4, boom. And again, if you didn't know how to do this, all of this, you have to still be able to get x equals 4 in the calculator, okay? All right, so next one, we're trying to see where it is defined. Keyword here. How do you do that? You set the denominator equal to 0. So actually, they got me. We're not looking to see if it's undefined. We're looking to see in simplest form, okay? So again, since it says is equivalent to, you can look and see, like store a number in for this whole thing, and see which one matches. My dog saying hi. And you should be able to take a look at this and say, okay, so this one right here is not factored. This one is not factored in simplest form. It could still be factored, right? X plus 3, x minus 3 divided by x over x minus 3, and then these cancel out, okay? So your answer is going to be x plus 3 over x. So all of that to say, number 4 is not factored as much as possible, so it cannot be one of the answer choices. You can just actually eliminate it right now. But how do you do this problem? Okay, let's see. So what we're going to do is we're going to factor the top. So how do we do that, right? We split it down the middle. And so we say we have x to the third plus 2x squared. And on this side, we have negative 9x minus 18. And so we factor the left and we factor the right, okay? So here I have x squared that can come out, and I'm left with x plus 2. So I know I'm going to have an x plus 2 on this side, and a 9x has, I'm sorry, not negative 9 has to come out for that to happen. So now what is my top going to look like, right? The x plus 2 is in common, so I'm going to write that out. And I'm left with x squared minus 9. And just like we said before, this can be factored further. So it's going to be x plus 2 and x plus 3, x minus 3, okay? So that's what our whole top looks like. So let's just write that down, right? I have x plus 2, x plus 3, and x minus 3. That's my whole top, okay? Now I'm going to do the same thing to the bottom. I'm going to factor the bottom, okay? So I see that x goes into all of them right off the bat. So I'm left with x squared minus x minus 6. So I'm looking for two numbers that multiply to give me negative 6 and add to give me negative 1. So what are those numbers? 3 and 2. Okay, so 3 and 2 do work. This is going to be a negative 3. Okay, so I have x minus 3 and x plus 2. I factor out the x. Okay, so now I rewrite my bottom, x parentheses x minus 3 and x plus 2. and let's see what cancels out. Okay, let me get my red marker here. So x minus 3, x minus 3 cancels out. X plus 2 and x plus 2 cancels out. So what am I left with? I'm left with an x plus 3 on the top and an x on the bottom. Okay, so that is answer choice number 3. And people might be tempted to go ahead and cancel out these x's right here, the top and the bottom one. Okay, you cannot do that. You cannot cancel these out right here because this is plus and this is division. They do not cancel each other out. So don't be tempted to do that. So our final answer is going to be x plus 3 on top and an x on the bottom, which is answer choice 3. Okay. All right, so the last of the polynomials, we're almost done. Ren multiplied both sides by the least common denominator. Which statement is true? All right, so for our next problem, what I started out by doing is going to my calculator, putting this under y1, putting this under y2. And it says multiplied both sides by the least common denominator. Which statement is true? So we want to see extraneous solution. So automatically I can see that 2 is an extraneous solution because if I plug it in here, 2 minus 2 is equal to 0. We can never have a 0 in the denominator. That can never happen. Okay, so looks like my answer choice is going to be 1. And if I take a look at the 7 halves, because it also says 7 half is an extraneous solution. If I go to my table, I can't put 7 halves for my x, so I want to go to second window. Let's put my 7 halves here, 7 divided by 2, and if I go to my table now, across from 7 halves, which is 3.5, I see the same number. So 7 halves is not an extraneous solution, it is a regular solution, so that is out. 0 and 2 are extraneous solutions. So now, let me talk about that, okay? If you were to do this question the longer way, like actually multiply it by our common denominator here, like here, this is x parentheses x minus 2. So here we have an x minus 2, so what's missing is an x. Whatever I multiply by the bottom, I multiply by the top. Here I have an x, what's missing, x minus 2, multiply the top by x minus 2. And now the denominators are the same, so I can cancel them out. So this whole thing goes away. Oh, let's get rid of that. I went orange instead of bright red, fine. So then on the left-hand side, I have 2x times x is 2x squared minus 11, right? Times x is minus 11x. Negative 11 times negative 2 is positive 22 is equal to 8. If I move this 8 to the other side, this is going to cancel out and give me 0, which is what I want. So I have 2x squared minus 11x plus 14. Okay, so here I have to do some AC method. This is in unit 5, so lesson 5. So AC method is I take A times C and I multiply that out. So 2 times 14 is 28. So I'm looking for two numbers that multiply to give me 28 and add to give me negative 11. Okay, so 7 and 4 looks like they work. Okay, and has to multiply to give me a negative. So this is going to be negative 7 and negative 4. Okay, so I can split this negative 11 into negative 4x and negative 7x. You could have left it with the negative 7 first, but I noticed that the 14 matches better with the 7. And again, this is just preference. Your 2x squared is going to come down. Okay, if this question's a lot, you're going to pick an answer and you're going to move on. Okay, you're going to factor the left, factor the right. So this is going to be x plus 2, x plus 2, and I see a 2x comes out. Does that work out? This is a minus, sorry. Went a little bit quick. So this is a minus 2 minus 2. And let's check that. 2x times x gives me 2x squared. 2x times negative 2 gives me negative 4x. So this is going to be a minus x minus 2 on this side. So this is going to be a negative 7 out in front. Okay, so now I'm going to write down my x minus 2 and write down what's left, right? The x minus 2 comes out, I have a 2x left. The x minus 2 comes out, I have a negative 7. Okay, so here are my factors, and then now I'm going to set them equal to 0. So I get x equals, change the sign here, so I get x equals 2. is one of my answer, and then I have 2x minus 7 equals 0, add 7 to both sides, and I get 2x equals 7, and this is where my 7 halves comes in, right? Divide both sides by 2, and I get x equals 7 halves. So x equals 7 halves works, and x equals 2, we just showed you, does not work, right? The calculator gave us that, and if you plug 2 into the denominator, 2 minus 2 is going to give me 0. We cannot have that. So the only solution that makes sense is option number 1. 0 is not even a factor here, right? 0 is not even one of the solutions. I didn't get x equals 0 here at any point, right? So it's not a solution, so that's why it's not number 3, and 4 is wrong, okay? All right, equivalent, again, you can plug into the calculator. How do you get this little cube root into the calculator? Let me just show you real quick. So if I hit alpha y equals to get my fraction bar, hit option number 1, how do I get the cube root into the calculator, right? I hit the math button, option number 4, right? And then I plug in x squared, and then I go to the right, put the times button, and then the square root. So this is square root of x to the 5th. And then on the bottom, I have the 6th root. So I put 6 in first, hit the math button, option number 5, and this is x. So I know I'm going to get a wrong answer because I didn't store this, but I don't want to waste my time that I just did. So I'm just going to hit enter into the calculator, and it's going to say, okay, so I'm going to say go to, okay? So here, let's see if it'll let me do anything else. Let's just do a quit. I might need to type it in. Okay, this is actually what I want. So I'm going to take my 2.1, I'm going to store it in for x, hit enter, and now I'm going to go up and grab this whole thing because I don't want to type it in again, and I'm going to hit enter. So my magic number is 9.261, 9.261. I'm going to see which one matches that, so automatically it's not that, right? If I do x to the 3 halves, alpha y equals, option number 1, if I put in a 3 and a 2 on the bottom, and I get my answer, that's not this one, right? So it's not number 2. If I plug in x to the 3rd, let's see if that works. There you go. So our answer is choice 3, okay? How do I do this the longer way? If you want to know, I needed to clear some space here, so I can rewrite this right here as x to the 3 is my root, roots go on the bottom, my 2 is my exponent, so the 2 goes on the top, and I'm going to multiply this by, I'm going to do the same thing, right? There's an imaginary 2 here, so 2 goes on the bottom, the exponent is 5, okay? And then it's all over the x, right, a fraction bar. The 6 is my roots, that goes on the bottom. If there's no number on the top, there's an imaginary 1, okay? And then it turns into an algebra 1 problem, okay? When I multiply with the same base, I take my exponents and I'm going to add them. So x to the 2/3 plus 5 halves, okay, all over x to the 1/6. So I take my calculator. Let's clear what's there. So I'm going to put 2/3 alpha y equals option number 1. There's a 2 on top, 3 on the bottom. And again, you should be doing this with me. Don't just watch me do it. And this is 5 over 2. And I'm going to hit enter, so I get 19 over 6. So this equals x to the 19 over 6 over x to the 1/6. When I'm dividing with exponents, I subtract them. So x to the 19 over 6 minus 1/6 is equal to x to the 18 over 6, and 18 divided by 6 is 3, which is that answer. Okay, so if you know how to do this stuff, for some of you it might be easier. This one is also another straight calculator question. I put this up so you can plug this into the calculator. If you get stuck along the way, ask me. So for this one, you're going to see the one that is equivalent is choice 2. And again, if you don't know how to do that, then let me know, okay? That is polynomials. We are now going into exponential functions. That's 30 minutes so far for polynomials. Not bad. I'll take it. All right, so the easiest way to do this type of question, which statement is true about the graph, is to go to the calculator and type it into the graph. So we're plugging in y equals 1 over 8 to the x. So go to my calculator and I'm going to plug that in to the calculator and hit graph. And now you're going to use this to see which one is right. So it's definitely not increasing because remember, we're always looking from left to right. It is not increasing. The function is actually going like this. So it looks like the answer is 2, but we got to check that, okay? So it says the graph passes through 1 comma 0. Go to my table. Across from 1, right? I don't see 0 there. So no, this is not true. The graph has an asymptote at x equals 0. X equals 0 is the y-axis, okay? And if I look at my y-axis right here, there is no asymptote. Remember, asymptote means that it's going to approach but never cross. Actually, the graph has an asymptote at the x-axis because if you notice, it's getting very, very close, right? But it never crosses. If this is the x-axis right here, it never crosses and it goes to the negative side. So that answer is choice 4 is also false. The only one that might make sense is option number 2. Okay. A house purchased 5 years ago for $100,000 was just sold for $135,000, assuming exponential growth. Okay. Approximate the annual growth rate. So just to refresh your memory, exponential growth rate is y equals a b to the x. Another formula that might come to mind is a equals p, 1 plus or minus, right? In case this is growth, so it's going to be plus r to the t. So we're looking for our rate here, okay? So our original amount is 135,000. No, 130. That's how much it was sold for. 5 years ago it was 100,000. So 100,000 is going to be our principal. That's the first number that we have. And then our time is going to be 5 years ago, and the 135,000 is going to be how much it's worth now. Okay. So how do you figure out what is your R? Pretty straightforward, right? If there is 100,000 times, the opposite of times is divide. So let's divide both sides by 100,000. Okay, this cancels out. So the zeros can cancel out. So I have 135 divided by 100, which is 1.35 is equal to 1 plus r. And this is all raised to the 5th power. How do I get that r by itself, right? What's the opposite of 5th power? The opposite of a 5th power is our 5th root. So we're going to root both sides. All right, we're doing good. So we have the 5th root of 1.35 is equal to 1 plus r. To get the r by itself, I subtract 1 here. I should subtract 1, but I wrote r. Okay. Good. So now I have r is equal to whatever this thing right here is. So this becomes a calculator question. How do I get my 5th root in the calculator again, right? Put the 5 in, hit math, option number 5, that's 5th root. Then I put 1.35. Okay, move over, put minus 1, and this is my number. So this number is 0.0, what is it, 0.061, and it says round it to the nearest percent. This is a decimal. So to go from decimal to a percent, move the decimal 2 places to the right. So that's going to be 6 point, actually says to the nearest percent, so 6%. Done. So 6% is our rate. Okay. Inverse. All right, so inverse means f of x is y equals a to the x. So I'm going to inverse it by switching, right? So the y becomes an x, so I have x equals a to the y, and I'm looking to see which one gives me that. None of them has an exponent here, so I'm going to rewrite it with a log, okay? So log, so this is my exponent, this is my base. So the bases go on the bottom, the answer to a log is my exponent, okay? And then the x is going to go right over here. So I have log base a of x is equal to y, which is answer choice 3. Which statement is false? So this is another straight calculator question. I put this in so I can show you how to get the log base on the bottom, because if you just hit the button that's above the ln, that's just going to give you log. It doesn't allow you to put the little number at the bottom. So hit math, go down to the bottom, or hit the up arrow, go to log base. Now you can put the 6 and the x, okay? And it's asking you which one is false. Which one is false? So I go to my calculator, this is my display. And so what's happening here is it's not showing you, but this goes very, very close to the y-axis, but it never crosses over. And again, you should know that from graphing. If you don't, then learn it now, okay? And this keeps going up. So it says the graph has, so it's asking us, going back to our question, it's saying which one is false. So definitely highlight this part. This is very important. That means 3 are true, 1 is false. So it says the asymptote has equation y equals 0. So let's go to our picture. So y equals 0 is our x-axis. And so no, that's not true because look what's happening here, right? It crosses the x-axis. So that is actually false. Let's check the other ones. It says the graph has no y-intercept. So let's look. And that is true, right? Because remember what we said is happening here, right? It's getting really, really close to the y-axis, but it's never crossing it. So that is true. The domain is the set of positive reals. Domain is your x values. So if you take a look at this, yeah, our x's are all positives, right? It's all positives. It doesn't go here to the negative sign at all. So that is true, okay? The range is the set of all real numbers. Let's check that. Yeah, the ranges are y. It goes all the way down and it keeps going up, 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 up. If I'm being dramatic, it's going to go something like that. So that is true, right? Our y, any y value can be true. It can be part of our solution. So that is true. So the only one that's wrong is the first one. The next one, the x value of which function's x-intercept is larger. So we need to find our x-intercept here. This is where the y equals 0. So 2 is going to be my x-intercept. X equals 2. And then if we're not sure what the x-intercept is for the log x minus 4, go over here. Let's clear this, hit log, and then we're going to do x minus 4. Notice that there's no base. So let's see what is our x-intercept here. So our x-intercept here is 5, right? That's the only number that gives us 0 for y. So I have across from 5 is 0, so my x-intercept here is 5. Which is bigger, 5 or 2, right? 5 is bigger, so f of x has the larger x-intercept because it's x equals 5. So justify just means show work. So what I'm doing right now is showing where I work. I could do a graph right here if I wanted to as well. So I can show you what the graph of this looks like, which is boom, like that. So I can graph that to show my work as well, and I could say this is at 5. Whichever way you want to do it, as a table or as a graph, it's up to you, okay? All right, next question. We're doing good. All right, so in short, this is saying to you, right, this is a function and this is equivalent to this right here, okay? So what we could do is they both have d in it. So I could just say d is equal to 5. I can store a number in for d, or I could just replace d with 5, okay? So, and I also see that they both start with 100. So if I divide 100 here and I divide 100 here, these will cancels out. So I have 1/2 to the, right, instead of d, I'm going to put the number 5. So 5 over 8 equals e to the k times 5, okay? So now, low-key, this becomes a calculator question because I can literally just go like this. I can go to y1, plug this under y2, and see where they meet, okay? I'm going to have two things, and I'm going to see where they intersect. So let's do it, okay? So I'll go to y equals. So I typed in 1/2 to the 5/8 power under y1, and I typed in e to the x times 5. I used x instead of k because that's what I'm looking for. I'm going to see where they intersect. So x times, and remember, I just put d is 5. So now I'm looking to see where they intersect. So I'm going to hit graph. Okay, so looks like it intersects at a very small number, so it's not 11 or negative 11. So now all I do is second, trace. Option number 5 is intersection. Okay, I'm going to go to around where it is, enter, 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 and it's going to give me our answer, negative 0.087. So our K, aka our X, is negative 0.087. Done. Okay. Next one. Oh, so for that one you have to be a little creative. We could do it. All right. The next one we have compounded monthly, and then we want to see the function. So I want to refresh your memory about whenever you have compounded monthly, A equals P parentheses 1 plus R over N to the NT power is the formula that should come to mind when it says compounded. Okay. If it says compounded continuously, it's A pert to the RT. Okay. So this is compounded monthly. Our N is equal to 12 because there's 12 months in a year. It's 2.55%. So our rate is equal to 0.0255. So all I'm doing is I'm plugging in things that we know. 63,000 is my principal. So all I have to do here is a little bit of plugging. So my function is going to be read C of t is equal to, my P is 63,000, so I'm plugging in 63,000 here. It's going to be 1 plus, my rate is 0.0255, okay, divided by, my N is 12, and this is going to be raised to the 12 times t. We're using t because that's our variable that they told us to use, okay? All right, so there is my part 1 done. Now it says calculate algebraically, right? The number of years it'll take for the account to reach 100,000. So we're saying 100,000 is equal to this whole mess, 63,000, 1 plus 0.0255 over 12 to the 12t, okay? So we're looking for our t here. Okay, we could do this. Let's just say you didn't know how to do this, right? Again, I keep telling you, you could do y1, y2 here, get an answer. So you can get that t is about 18.14, and then you could be, you know, out of the 4 points here, you would be able to get 2, maybe 3, depending on who's grading your paper. But watch how you get all 3, okay? All the points for this. So this is being held together by multiplication. You could divide both sides by 63,000. 63,000. Make sure I have the right number of zeros. 63,000. There we go. So this cancels out. Beautiful. So this 0 cancels, cancels, cancels. So I have 100 over 63. 100 over 63 is equal to 1 plus, right, 0.0255 over 12 to the 12t power. Okay, so now I can go ahead and say, we can do log here. Watch me do this. So here is my base. Okay, this here is my base. This is my exponent. Can I do this in a different color? Okay, so base, boom, exponent, and then this is my answer. Let's call this my answer. Okay, so when I'm doing my log, my base is going to go on the bottom. So this 1 plus 0.0255 is over 12 is going to go on the bottom. The answer to a log is my exponent. So my exponent is 12t. And then the 100 over 63 is going to go here. Okay. So now if I have this, how do I get the t by itself? Divide both sides by 12. Divide by 12. The 12s cancel. Okay, so now this is just something that I can plug into my calculator. Oh, wow, 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 wow. Okay, so the second. All right, so first thing I notice is there's a big old fraction option, alpha y equals. So log with the base on it. So I'm going to do math, go down to log base. And this is all just plugging stuff into a calculator. So I have 1 plus and another fraction here, alpha y equals option number 1. You see what I'm doing? 0.0255 over 12. Okay, and then I'm going to go to the right. Here I'm putting another fraction, alpha y equals option number 1, putting the 100 on top and the 63 on the bottom. Okay, nothing is hard, just plugging it into the calculator, and then I'm going to hit enter. And look, so t is equal to about 18 point, what do we have? What do we have? What do we have? 18.14. And it says to the nearest hundredth of a year, so that's why I left it to the 14. Okay, so there's my answer. Okay, that wasn't bad. Looks a little crazy, but whatever. All right, so compounded continuously, we talked about this. This is a PERT. First thing to notice, let me get rid of that. There's a lot of things open. So we're not scared of this. We're just plugging stuff in. So to the nearest 10th of the year, how long will it take for an investment to double? So let's just say the starting amount is 100 and it's going to go to 200. Okay, you could have picked anything you wanted. You could have picked a billion, a million, but I want to try to make it as easy as possible. Okay, so we're going to have 200 equals, the starting amount is 100. Our rate is 3 3/4. Okay, so let's talk about that real quick. 3 3/4 is the same thing as $3.75, and this is our percent. So we have to move the decimal 2 places to the left. So it's 0.0375 is going to be our answer as a decimal. Okay, so this is our rate. All right, so I have 0.0375, and then this is going to be t. Okay, all right. So now how do I get, actually, they don't even tell us that they want us to do it algebraically. So you could, again, y1, y2, but I'm just going to do this the longer way. For people who are like, can you show me how to do this? 200 divided by 100 is 2 equals e to the 0.0375t. How do I get rid of an e, right? Let's remember our calculator. Where is the e located? It's right above the ln, okay? So the opposite of e is ln. So I'm going to use my different color. ln the left, ln the right. As soon as the ln and the e are next to each other, they cancel out. So I have ln of 2 is equal to 0.0375t. Get rid of the 0.0375 by dividing. Divide by 0.0375. And we just did this in the last problem. Similar, right? So I go to my calculator. Alpha y equals option number 1. ln of 2, right? Close those parentheses over 0.0375 and hit enter, and t is about, and it says to the nearest tenth of a year, so this is going to be 18. Why do they love 18 so much? I don't know. Where's my calculator? 18.5. 18.5 is going to be our how long years. All right. Cooking with gas. Inverse. Okay, so f of x is y equals, take x and y and switch it. So x equals y to the third minus 2. How do you get the y? So this answer is not there as is. How do you get the y by itself? Plus 2 cancels out. X plus 2 equals y to the third power. Okay, how do you get rid of a third power? By doing a third root. So third root. So these cancel out. So I'm left with y equals the cube root of x plus 2. And when you're cube rooting something or square rooting something, it's going to be positive and negative. So that is answer choice 4. And you can prove that to yourself because the cube root of 27 is equal to positive 3, because 3 times 3 times 3 is 27. And also 3 times 3 times 3, 27. Yeah, good. And then does the negative work? Negative times negative is positive, times negative is a negative. So in this case, actually, it's just going to be, oh, I got tricked here. It's actually going to be number 3. So let me just kind of go back real quick to that. I'm kind of glad that I made that mistake. So the square root of 9 is going to be positive and negative 3. The cube root does matter, right? So this is going to be just positive 3. Negative 3 does not work. Okay, so that is option number 3 is our answer. All right, for this one, so we have a degree 4 polynomial, which means you have x to the fourth. So we talked about this, right? End behavior is going to be either up, or if the leading coefficient is negative, it's going to be down. This is like negative. So which statement is incorrect? So highlight this. So 3 are correct. So the degree of the polynomial is even. Yes, it is. That is an even number. So that is true. There is a positive leading coefficient. That's wrong, right? See, these two are built facing down. So that is not true. At 2 pH values, there's a relative maximum. Yeah, somewhere around here and here. There are relative maxima. There are 2 intervals, so this is true. There are 2 intervals where the function is decreasing. So again, we're looking from left to right. Right here, the function is decreasing, and over here, the function is decreasing. So that is also true. So option number 2 is the one that is false. Okay. 27. Well, not 27, but you know. Next question. Just so you know, in between every single question, I just reset the calculator. I know it takes like 10 seconds. How do you do it? Second plus gives you this menu, 7, 1, 2. Okay. All right. So now I have a fresh calculator to start. So since it says average rate of change, right? Unit 1, lesson 1. So we're going to go ahead and just take this and plug this into the calculator. Instead of the t, I put an x, and then I'm looking for, here's my x1, here's my x2. So across from 4 and 8, I need to find the numbers. So if I go to my table, so I'm looking across from 4. I have this number right here, 2742. Point, and you want to try to get as exact as possible. You see the numbers in on the bottom, it says y1 equals 1636 40 18, 1636 40 18, right? So it still does round it, but I have a good approximation, and I'm going to do the same thing for number 8. I'm going to go across from 8 and look at what number is there. So I have 2937 point, and I have a bunch of other numbers, right? 28, 96, 20, 91. 28, 96, 20, 91. Is that right? I'm just probably making stuff up at this point. No, I'm right. Okay, so now I just label, right? X1, X2, Y1, Y2. So remember our formula, Y2 minus Y1 over X2 minus X1. So there's my formula that I'm plugging into my calculator, and when I plug it into the calculator, I get 48.78. Rounded to 2 decimal places is my answer. Why? Because it says rounded to the nearest hundredth. Okay. Did I finish? Determine the average rate of change around here. Okay. Algebraically determine whether it's odd, even, or neither. So this is another calculator question. So if I graph it, I can automatically see that I have something that looks like this, right? It goes down, it goes up, comes up. Okay. So since it is symmetrical with respect to the y-axis, right? Like my y-axis is like my mirror, and if I fold it along that y-axis, it's going to be symmetrical. That means it's even. It says to do it algebraically. So for example, if you did do this on the regents, we would get 1 point out of the 2, okay? So how do you do it algebraically? Wherever you see x, you're going to substitute in with negative x. So what do I mean? Right? This is going to be negative x to the 4th power minus 3 times negative x to the 2nd power minus 4. Okay? You with me? So now, when I raise something to the 4th power, negative, 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 negative is going to be a positive, so that's just going to give me x to the 4th. Okay? Then there's a minus 3. Negative squared is going to also give me the same thing as x squared. And then that minus 4 comes down. Since this right here is the same exact thing as this right here, this is an even function. Okay, that's how you get your full 2 points. If you did it graphically, you would get 1 out of 2. If you just do it algebraically by plugging in, instead of x, plug in negative x. And if you get the same function, it is even. If you get the opposite, right, like if you got a negative, positive, negative, then that would give you an odd function. Well, negative, positive, and a positive. Then that would give you an odd function, okay? If it's literally the opposite or the inverse. All right, this question, no one should get any of these graphing questions wrong. It's literally straight free points. This is a free 4 points, okay? So let's do this. So after I graphed it, right? So I went to my y equals, I plugged it in. Then I go to my table and I look for some patterns here. So if I go to the negative side, this number is getting very, very close to 2, but it never gets bigger than 2, okay? So, okay, so that's good for us to know. So at negative 10, okay, so negative 10, my number is going to get very, very close to 2. I'm not going to touch 2, okay? And then if I go, this is where the calculator is actually lying to me. It's actually getting very, very close to 2 on the left-hand side, okay? Negative 7, right? So I'm going to go back to my thing. Negative 1, 2, 3, 4, 5, 6, 7. I'm going to also go to 2 or somewhere around there, right? So at what point does it start curving down? So what I'm doing is I'm looking, going lower over here. Okay, so across from 0 is 1.89889. So 0, 1.889. So you see what I'm doing, right? It's getting very, very, it's getting a little bit further away. And then if I go down, I see that across from 2 is 1. So that's another definitive point. Across from 2 is 1. If I keep going down, right, I have 3, negative 1. So 3, negative 1. Let's put my dot. Go down 4, negative 7. I'm just counting and drawing, okay? And then can I get one more in? No. So 5, negative 25, there's no way I can graph that, okay? So now what I'm going to do is I'm going to take my pen, pencil, whatever you have. Graph should be done in pencil. And then you're going to try to connect these dots as best as possible. It's hard for me to do on the computer, but you'll get the point, okay? And you're going to draw an arrow, okay? So now let's see. Describe the end behavior of c of x, which is a function that we just drew, as x approaches positive infinity. So as we get to the right, what is happening to our y, right? And we can see it. It's very obvious, right? As we go to the right, our y is going down, right? So c of x, right, is going down towards negative infinity, right? That is what we call down, right? All the way down here is negative infinity, okay? All right, describe the end behavior of c of x as x approaches negative infinity. So now as we're going to the left, we kind of already talked about this, right? The number is getting very, very close to 2. It's never going to cross and go to 3. It's getting very close to 2. So c of x is going to approach the number 2, okay? That is our full 4 points here. Next one, we're going to go ahead and graph. This is from the August. This is a little bit more recent. Okay, so we're at the 1 hour mark right now. Should definitely go take a break for a little bit. If you haven't, if you're sitting through this whole hour right now, stop, ask to go to the bathroom, stretch. If you're at home, you don't need to ask to go to the bathroom, but you get what I'm saying. Take a little bit of a break right here, okay? All right, and we're back. So the first thing you're doing is, I just reset my calculator. Who has time to sit there and figure anything else out, okay? So I plugged in my function, which is right here. So it says models volume, beautiful. They only want us to graph it from 0 to 3. That's it. So I'm going to change my window, right? Let's change my window. Let's go to my X min 0. My x max is going to be 3. All right. And what is my y going to look like? So let's see. So now let's go to my graph, my table. So, okay, so for right now, since I have 0, 1, 2, 3, I'm looking for my y. The highest number that I have is 12. Okay, so let's see if I can go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, let's just go by, that's fine. So now I'm going to go to my calculator. Across from 0 is 0. So I'm going to put my dot at 0, comma 0. And then my next number is 110. So 1, right? 10, boom. Across from 2 is 12. So 2, 12. Let's put our dot. And across from 3 is 0, right? So 3, 0. So 3, 0. Okay. So now there, I want to try to be exact as possible. So let's hit graph so I can see what's happening here. Okay, so I have something, it goes up, goes to 12, comes down and hits 3 at 3, 0. Okay, so let's change my window for my y's, and let's not make it 12 anymore. Let's make it 15, because this is, right, here's 12. So 13, 14, 15. I'm taking time right here to show you how to do this. So please do this along with me. Don't just watch me do this. And it's going to drop suddenly. So that's what I have to do, okay? At some point here, there's going to be a max. So if I wanted to find it, I could press option number 4 here. So left bound, hit enter, and go a little bit to the right of my highest point. I'm just trying to see what is my highest point. It probably is 12, but I just want to be safe. And then I want to go to where I think it is. Okay, and hit enter. And it gives me 12.59. Okay, so about 12.6. And that's across from 1.69. Okay, so what does that tell me? That means somewhere around here, there's going to be a little bit number higher. Okay, so I'm going to take my pencil, again, try to graph this as best as possible. I even turned my computer screen so I could do this a little bit better. Okay, and boom, there we go. There's my graph. So look at me predicting. It says, what is the maximum volume, right? Kind of just did that. Here's our maximum volume. The maximum volume, the volume is our y, right? It's the v of x. So we already have our max volume, right? It's 12.59, and it wants me to round it to the nearest tenth. So this is going to be about 12.6. What is our units here? This is in cubic inches. So inches to the third power, or you can write 12.6 cubic inches, and that is our highest, okay? That's full points for that, okay? Recursive, so some sequences and series. All right, so straightforward. Watch how easy this is. So the first 4 terms, okay? They tell us that A1 is 3. So I'm just writing a 3 here. All good? All I did is A1 is equal to 3. I put my A1, I put 3 there. Boom. How do I get my further ones? Now I'm going to follow my rule, right? The rule says I do 1 plus 2 times, and then this an minus 1 thing is just code for whatever the previous number is. Watch what I mean. This is 2 times previous. This is my rule. I just decoded my rule. So to get A2, A3, and A4, okay, let's start with A2 first. I do 1 plus, this is going to be 1 plus 2 times whatever my previous number. This number is going to be 3, right? I'm going to take my 3 and plug it in here. What is 1 plus 2 times 3? 7, okay? Now here, I'm going to do 1 plus 2 times 7, right? The 7 is going to go over here. It's very simple. So 2 times 7 is 14, plus 1 is 15. Boom. This is going to be 1 plus 2 times, and I'm going to put 15 here. You guessed it. So 15 times 2 is 30, plus 1 is 31. So what are my first 4 terms? 3, 7, 15, 31. Done. Okay. So 2 points secured. Can this sequence be represented using an explicit geometric? Geometric means that you multiply to get to the next. Multiply to get to the next. And there is no number that I can multiply by to get to the next here, so you say no. Because there is no one number to multiply to get the next number. Simple. Secure that bag and move on, right? It says in the next one, which model is a recursive? So it has to have the an minus 1 thing in it. 1 and 3 are not even recursive, so why are we even going there? Okay, so it says depreciation, so that's going to be 1 minus our rate to the time, right? This is going to be t, and then our first number here, they're telling us is 75,000. 75,000. Okay, so 75,000. So what we're going to do to find the next number right here is we're taking our previous number. So this is going to be 1 minus 8%, right? 0.08 is equal to 0.92. That's where they're getting that from. And so we're going to do 0.92. And remember what we said, it has to use this annotation to it, right? The an minus 1. So that is option number 4. Okay. Actually, that's the only one that has an minus 1 in it that's using any sort of recursive. It gives you the first term, right? It gives you how to find the next terms. All right, so that was a lot easier than I just made it right now, but oh well, good practice. Alexa earns 33,000 in her first year of teaching. Actually, fun fact, teaching, my Alexa's going off. Alexa, off. Yeah, this person earns 33,000 in her first year of teaching and earns a 4% increase. So at this point from units 1 through 3, we technically did not do this in Algebra 2 yet. However, watch this. Watch me whip. So this right here is my first term. So it earns a 4% increase. What is that getting increased from? 100%. 100 plus 4 is 104%. What is this as a decimal, right? Move the decimal 2 places to the left. So doot doot. So this is 1.04. Okay. So that is our rate. All right. So it says write a geometric series. This is right from your reference sheet. Reference sheet, last page of the booklet. As soon as you get your test, rip it out, write down things that you need to remember that's in short-term memory, and then begin. Okay. So now we're just taking this and we're plugging this into this formula. So A1, so 33,000 minus A1 again, 33. Why am I writing so fast? I'm missing numbers. 33,000. And then this is going to be times R, which is 1.04 to the N. Okay, we don't know N years. All over 1 minus R is 1.04. Done. So next part. So that secured 2 points out of 4. Okay. Now they're even telling us this number is 15. You're going to plug in 15 here. So I just literally take this, plug this into my calculator, right? Look what I put in for n, 15, and hit enter. So I have 6. Oh, this is a lot. 15 years of teaching. Just add up all the numbers. 660. What is it? 778. 778 point. And this is to the nearest cent. So 39 cents. Okay. So this is how much money she has secured after 15 years of teaching. Okay. Doesn't seem like a lot, but it is. It's not bad. All right, solve the equation. So this is a story about a negative boy. This boy had a choice to go to a radical party, but the boy was a square. He missed out on 4 awesome chicks, and the party was all over at 2 a.m. Okay, so what is each? A is 2. It's the number in front of the x squared. B is 5. It's the number in front of the x. And C is 8. So the formula says, okay, we're going to plug it in here. So whatever b is, we're going to make it the opposite. So negative 5 plus or minus the square root of b squared. So we're going to do 5 squared minus 4 times a times c. Do you see what I'm doing? All over 2 times a. Okay. Now I'm going to take my calculator. Okay. Clear what's there. I'm not putting on the radical there. I'm just putting what's under the radical. So 5 squared minus 4 times 2 times 8. Hit enter, and I'm going to get negative 39. So this is negative 5 plus or minus the square root of negative 39 all over 2 times 2 is 4. Okay. It says to write your number in a plus bi form. Where is the I coming from? Right here. There's an I, right? Because there's a negative under a radical. Square root of 39. This is 13 and 3. That doesn't help us. So we could just leave our answer as negative 5, right, over 4, because this is like Band-Aid method, right? This shares a 4, and so does this right here. So this is plus or minus. So I'm going to do radical 39 I over 4. That's my whole answer, okay? So the radical 39, the I came out. There's a 4 on the bottom. Why did the I come out? Because it told me to put the I at the end. So I do that. Equivalent. Beautiful, right? Straight calculator. Store number in for X. So 2.1 gets stored into X. Hit enter in the calculator, right? And then match. That's the easiest way to do this one. If you're like, Miss, show me the longer way. No. Okay. See me. If you want me to show you the longer way, see. It actually winds up being the first one. Okay, and again, if you want me to show you how to do this, see me. I'm going to do this second one first because it is a straight graph. Let me show you the basics and then I'll show you the level 2. Okay, focus is negative 3, 3. 1, 2, 3. Positive 1, 2, 3. Dot. That's my focus. Okay, the directrix is y equals 7. So 4, 5, 6, 7. So this right here at 7 is my directrix. So I go halfway between my focus and directrix. That's going to be right here, right? What's the points of that coordinate right here? Why can't I think anymore? All right, so this is going to be negative 3 comma, and I'm going to move up to right between. This is 3, that's 7, halfway in between is 5, okay? How do I know that 3 plus 7 is 10? Cut in half is 5. So negative 3 comma 5 is my h comma k, okay? Now my p is equal to, so I know my parabola is going to be facing down because it can never cross my directrix, okay? It can never cross my directrix. So I know that it's going to be negative. And what is the distance between 5 and 3? This is 2, okay? So here's my formula. This needs to be memorized. If you don't know it, learn it, please. This is a freebie. So straight plugging in, right? So my h is negative 3. So it's going to be x minus negative 3 squared plus k. K is 5, right? So you're literally just plugging in 5 here. 1 over 4p. My p is negative 2. So y equals, okay? Simplify this mess. So 4 times negative 2 is negative 8. Automatically, these two are out. Negative is going to give me a positive. So this is y equals 1 over 8. This is negative. This is x plus 3 squared plus 5. Which one matches that? Choice 3. Okay. This is level 1. A focus and directrix. Let's do a level 2 question, okay? So level 2 question is going to be the one right above it. So the directrix of the parabola has an equation y equals negative 6. So I'm going to, just like I did before, I'm going to graph this. So 1, 2, 3, 4, 5, 6. At negative 6, there is a directrix, okay? Find the coordinates of the focus. Oh my goodness. Okay, doable. Okay, so this is why I call this a level 2 problem. So you see this format, the way that they wrote it, they have this x minus 4 squared by itself. They have this part right here by itself. So let's move things over. Let's move that k over. Boom. Straight algebra 1, nothing crazy. 1 over 4p x minus h squared. Okay. You have to get that x minus h squared by itself. So let's get rid of the 1 over 4p, multiply by the flip. So the flip of 1 over 4p is 4p. Whatever I do to the right, I do to the left, multiply. So this cancels out. So I'm left with x minus h squared equals 4p y minus k. Okay. Why did I do that? So I can do some matching. Okay. So I have my h is right here. Look what number's here. My h is 4 is what it's telling me. Okay. So I have a coordinate 4 comma, and then my k is the number, k is right here. What number is there? It's positive 3. So remember the formula is y minus. A negative negative gives me a positive, so this is going to be a negative 3. So 4 negative 3. Watch. Ready? So I'm going to go 4, 2, 3, 4. So 4 negative 3, and that point right there is my vertex. So I have my directrix and I have my vertex. Okay. All right. So this is a good sign. So we're actually low-key almost done, right? Here's my directrix at negative 6. So this is 3 away. Okay. So to get my focus, which is what I'm looking for, I have to go 3 this way, right? This coordinate here is 4 comma negative 3. So if I add 3 to that y, right, if I go up 3, this point right here is 4 comma 0. So my focus is 4 comma 0. Okay. Oh, not too bad. All right, so now these questions, these are quick hits. These weren't covered yet. We're almost done. An hour 16. I thought that this was going to take 3 hours long. Not bad. 80% of the course right now with units 1, 2, 3. Intense review. We got this. You asked for it. I delivered. Okay. All right. So whenever you have a question that has something like this, okay, distributed, the mean is 680. The standard deviation is 120, and they want it between 2 scores. So the first number is my lower, the second number is my upper. Okay. So where do I go to put this into the calculator? If you did the June and the August regions, you should be in good shape. So you hit second and VARS. VARS is right next to clear, and you're always going to do option number 2. So the lower, we're going to replace it with 690. The upper, we're going to replace it with 900. The mean, they told us, see, they told us the mean is 680, so we're going to put 680 here. Hit enter. Standard deviation is 120. Hit enter. Enter again. Enter again. And this is our number. This is our answer. It says to the nearest percent, so I'm going to take that decimal point for the 0.433 and move it 2 places to the right. That's 43% to the nearest percent. Done. Okay. My phone is ringing. All right, so for our next one, it says find state and exponential regression equation model. So how do you go into the calculator and enter this in? You hit stat and edit. Okay, so let's do that. Let's go to our calculator, hit stat, so under delete, edit is option number 1, and we're going to put the numbers in here to the calculator, then go over to stat, go over to calc, and again, you should be pausing the video so you could do this yourself. Go to xbreg and literally just hit enter, enter, enter a whole bunch of times. And then when you do this, you're going to get our answers. And it says rounded to the nearest thousandths place. So we have 2.459, looks like. So y equals 2.459. That's our A. Our B is going to be 1.616. And it's to the right, to our x power right here. So that is going to be our function. And we have rounded all our values to the nearest thousandths, tenths, hundredths, thousandths. Okay, good. All right, so our next question, again, we didn't do this, but if you feel like you understood every single other thing that we've done and you're like, hey, give me another easy point. Anytime you see the word given, there are 2 categories here. One of them is says randomly selected donor was characterized as a supporter, and that the donation was made online. So what we want to do is given. Anytime you see given, you check and see on the top which one is both of those, online and supporter. Supporter. Divided by whatever is second. So the total number of donations online, so total online is second. So here I'm just going to go ahead and show you what I mean. So online and supporter, right? Those are our two categories. So that is 1200. So 1200 goes on top. Okay. And then the total number of online. Okay. So we're going to go to online total. We're going to take these numbers here and we're going to add them up. So when we add them up, we get 3216. So on the calculator, I'm going to go to my regular calculator here. Alpha y equals option number 1. So I'm putting 1200 on top. And then if you don't know to add them, if it's not easily addable, you could put 1200 plus 2016 on the bottom and hit enter, and it gives you this. You want it as a decimal, so hit math. To decimal is option number 2, hit enter, so we get 0.373. So this is going to be to the nearest thousandths is 0.373. Okay, there is our answer for this question. So there's the work, and there's our answer. Next one, theta is in angles in standard position, so we want to draw it. Terminal side passes through -2, -3, so -2, -1, 2, 3, and I'm going to put a dot. Okay, what we want to do is we want to connect it to this point 0, 0 right here, and we want to put a right triangle with respect to the x-axis. So here's our right triangle and here's our theta. Okay, so just to refresh your memory, opposite the right angle is called the hypotenuse, and the side that's left over is called adjacent. So whenever you see or think of things like this, think of SOHCAHTOA. Specifically in this case, we are looking for tan. So tangent is equal to O stands for, this O stands for opposite over the A stands for adjacent. Okay. So what did they give us? Boom. They gave us that this is -2, and they gave us that this is -3. Okay. So our adjacent is -2 and our opposite is -3. So now we're just writing it as a fraction. We're going to put the opposite first, which is -3 goes on top, and then the adjacent side goes next, so -2. -3 divided by -2, negative divided by negative is a positive, so that's going to be 3/2. Okay, I'm going to ask you one more thing. If they didn't give us the hypotenuse and you need to find like cosine or tan, where you need to find the hypotenuse, you have to use some Pythagorean theorem here. So remember, a squared plus b squared is equal to c squared. You do need to remember that the hypotenuse is always our c. This is our hypotenuse, okay? So if you're given the hypotenuse and you're looking for adjacent, or you're looking for the hypotenuse one, then you have to use a squared plus b squared equals c squared. All right, and hour 23, this next one, I did go over it in the video for, I believe this was the June 2023, yes, okay. I did go over it with the video, but I'm going to just show you this one more time, just want to make sure. So, well, first thing we want to do is we want to look for the midline. So this number right here, our midline is at 2400. If you want to know this a little bit more, please see the video for the June 2023 Regents. This is on Delta Math. So our C is 2400, okay? So first thing we want to do is we want to write that down. So this is going to be plus 2400. All right, one letter out of the 3, done, okay? Then we want to find our A is our next easiest to find. So how do you find the A? Let me do this in burgundy, right? The A is going to be that distance from the height to the midline, or from the midline to the lowest point. So how many numbers is that? This is 200, 400. So our height, our amplitude, our A here is going to be 400. So 400 is our height. Okay, so we have 400, we have sine, and now we're looking for our B of t. How do we find our B? Let me do this in green, okay? So this right here is how long to make a full cycle. Okay, so a cycle means you start at a point, you go up, come back down through that point, you go down and get back. So how long did that take us? That took us 5 seconds long. So this is going to be 5t. So the 5 is how long it took to make a full cycle, and 2 pi always goes at the top. So our full formula here is n of t is equal to 400 sine 2 pi always goes on the top. It took 5 seconds to make a full cycle. Don't forget the t, like I did, and then plus 2400 is our midline. Okay, that is the equation of our graph. And so these are some things that's coming up in the non-negotiable videos. I may or may not get time to do this. My goal is to do it, but an hour and 25 minutes to go over everything that we've covered, 80% of our course, which is units 1 through 3. Not bad. I'll take it. Okay. Good luck.